Okay, so thermodynamics, as the name suggests, it deals with transfer of heat. Means there is movement. It is related to movement of heat, or we can say transfer of heat from system to surrounding or surrounding to system. And you know what is system and surrounding? So first of all, we will discuss the first law of thermodynamics, state function, or we can say state variables. So what are state variables? Okay, means we can say those are state functions, because state function means those properties of the system which depends on the state of the system and independent of the path followed. State variables means temperature, pressure, volume, number of moles, means PV equal to nRT. These are the components. So if they vary, state of the system changes. Okay, so out of these four, one can be fixed, because if we fix 3 out of 4, fourth is automatically fixed. So out of these 4, 3 components, if they vary out of these 4, then the state of the system changes, and those are called state variables. And what do you mean by your first law of thermodynamics? It is just law of conservation of energy, and mathematical form is delta U equal to Q plus W, and Q is, if it is positive, means heat is absorbed, yes, and if it is negative, heat is released by the system, and W is work done. If it is on the system, then it is positive, and if work is done by the system, then it is negative. So this is the first equation we have to keep in mind. And what is delta U? Could you define it? It is the energy absorbed or evolved at constant. What is constant here? No, only constant volume. Okay, so delta U is heat absorbed or evolved at constant volume, means whenever we have a closed system whose volume is fixed, then heat absorbed or evolved in that system is called delta U. And best example is bomb calorimeter. Bomb calorimeter is used to measure delta U. Okay, now second is delta H equal to delta U plus P delta V, or delta H equal to delta U plus delta NGRT. And what is delta H? Again, heat absorbed or evolved by the system at constant pressure. See, delta U was at constant volume, right? Change in internal energy, and this change in enthalpy is the heat absorbed or evolved at constant pressure. Now, if we have a reaction like N2 gas plus 3H2 gas to give 2NH3 gas, what is the relation between delta H and delta U for this particular reaction? Delta H, okay, because here delta Nj is, yes, case 1, if delta Nj is less than 0, then delta H is less than delta U. If delta Nj is greater than 0, delta H is greater than delta U, and if delta Nj is equal to 0, then delta H is equal to delta U, right? So in this case, delta Nj is, it is product minus reactant, so 2 minus 4, that means minus 2, so it is less than 0, so delta H is less than 0. Now, what is the relation between delta H and delta U? Delta H is, yes, it is delta H equal to delta U, because here delta Nj is 0. Okay. Now, work done in an isothermal and reversible process. So if work is done in the isothermal and reversible process, means isothermal means delta T is 0. So if delta T is 0, delta U is 0. So if delta U is 0, Q plus W is 0. That means Q is equal to minus W. And work done in isothermal and reversible process, that is equal to minus 2.303 nRT log of V2 by V1. Or come again? Okay, great. See, when you are talking about internal energy, that means it is the total sum of all types of energies present in the system. So when temperature does not change, energy is proportional to temperature. So when temperature remains same, that means energy will not change. Yes, they can change internally, but total energy remains same. And internal energy is the total sum of all types of energies. They can transform from one form to another, but total nutshell, total sum of all types of energy is delta, is U, right? So that will not change. Okay. Okay. Same delta H, even delta H is 0 if isothermal condition is there. Okay. Now, according to that law, Boyle's law, at constant temperature P1 V1 equal to P2 V2. So V2 by V1 equal to P1 by P2. So you can write P1 by P2 instead of V2 by V1. And N is number of moles, R gas constant. Value of R, it is given sometimes, but what is the value of R in joule? Yes, 8.3. Okay, good. Now, work done in an irreversible process. So it is minus P external into delta V. That means for irreversible process, external pressure is constant. If anywhere it is given at constant pressure, that means it is irreversible work done. Now, irreversible work done takes place in one step because it is like this. Like this is pressure, volume goes from V1 to V2. So this area under the curve, if we plot pressure versus volume, then area under the curve represent work done, right? But if we have reversible process, then it goes in steps. So more is the number of steps, more is the work done. As n increases, means number of steps increases, reversible work done means work done increases. So that's why reversible work done is greater than irreversible work done. Now come to next, that is heat capacities. So heat capacity is the amount of heat that is required to raise the temperature of system by 1 degree Celsius or 1 Kelvin. So that means its unit is joule per Kelvin. It is the amount of heat required to raise the temperature by 1 degree Celsius or to decrease the temperature by 1 degree Celsius. That is the amount of energy released. Now specific heat capacity per gram. It is per gram because it is specific heat capacity. Specific heat capacity is the amount of heat required to raise the temperature of 1 gram of system by 1 degree Celsius, and molar heat capacity, as the name suggests, 1 mole. Molar heat capacity is Q upon N delta T. So out of these three, first one, it is an extensive property. The extensive property is the one which depends upon the amount of the substance. So if we heat 100 gram, 200 gram, 300, because mass is not mentioned. So if we increase the mass, heat capacity increases. That means it is an extensive properties, and these two are intensive, because this can be written as C upon M. This can be written as C upon N. So C as well as M, C as well as N, both are extensive properties. So if we divide two extensive properties, we get intensive property. Like mass and volume are extensive, but density is intensive. Okay. Now relation between Cp and Cv. So you know what is Cp? It is heat capacity, or yes, molar heat capacity at constant pressure. So it is amount of heat absorbed or evolved at constant pressure divided by this. So that's why we write here delta H by delta T. So it is delta H equal to Cp delta T, and Cv is molar heat capacity at constant volume. So for that we use delta U. So that implies delta U equal to Cv delta T. And from this relation, delta H equal to delta U plus, H equal to U plus RT, we can say if there is a change in temperature, so delta H upon delta T equal to delta U upon delta T plus R. That implies Cp equal to Cv plus R, means Cp minus Cv equal to R. Okay. Then you know this Poisson's ratio. It is, I think it is in physics, but there are few questions in chemistry as well, that this is Cp by Cv. So in this case, Cp minus Cv equal to R. So Cp upon Cv minus 1 equal to R upon Cv. So it is gamma minus 1 equal to R upon Cv. That implies Cv equal to R upon gamma minus 1. And value of gamma, it is 1.66 for monoatomic gas, 1.40 for diatomic gas, and 1.33 for triatomic gas. Then next is delta G equal to delta H minus T delta S, that is Gibbs Helmholtz equation. So for spontaneous process, delta G should be less than 0. So delta H, delta S, delta G. So if delta H is negative and delta S is positive, that means increase in enthalpy, decrease in enthalpy and increase in entropy, they are favorable factors. So delta G is less than 0 at all temperatures. That means such a process is spontaneous at all temperatures, because decrease in energy and increase in entropy. Entropy means, you know, measure of randomness. So that type of process is always spontaneous. And if we have just opposite, means increase in enthalpy and decrease in entropy, so in that case delta G is greater than 0 at all temperatures. So such a process is always non-spontaneous. Then come to if one factor is in favor and other factor is against. So here enthalpy is favoring the process and entropy is against. So in such a case, magnitude of delta H, if it is greater than T delta S, then delta G is less than 0. So such a process is spontaneous at low temperature. That means exothermic reactions are spontaneous at low temperature, or we can say low temperature favors exothermic reactions. And if both are positive, so in such a case delta S is in favor. So here just opposite. So thus such a process is spontaneous at a high temperature. That means endothermic reactions are spontaneous at high temperature, or high temperature favors endothermic reactions. Okay. Now delta S is according to second law of thermodynamics, delta S is equal to Q reversible over T, or delta S total is equal to delta S system plus delta S surrounding, and delta G is equal to minus T delta S total. That implies if reaction is spontaneous, for spontaneous process delta G less than 0, that means delta S total should be greater than 0, and minus delta G is also equal to useful work done. If useful work done with like to produce electricity, delta minus delta G is equal to that useful work done. Then Carnot cycle, is it there in physics? Okay. So you know efficiency of a cycle, delta G by delta H. Okay, so efficiency is, because delta G is, that is useful work done, and delta H is the input. So that is, we can calculate efficiency of a cell, or efficiency of, like in fuel cell we can use this formula, delta G equal delta H, delta G by delta H. So delta G naught is equal to minus 2.303 RT log of K, delta G naught minus 2.303 RT log K. K is equilibrium constant. So if delta G naught is less than 0, that means K should be greater than 1 for spontaneous process, and at the same time it is equal to minus NFE naught cell. So E naught cell should be greater than 0. Same delta G is equal to minus NFE cell. And you know number of electrons gained or lost, and F is Faraday. So yes, Coulomb per mole. Okay, now if we have a process like delta G naught. So these are the value. Let us say this is reactant and this is product. So this is the minima. So that means if we start from the reactant or we start from the product, reaction should come to equilibrium, because if we start from here, we will have delta G naught negative, again negative. So equilibrium, at equilibrium it is 0, because at equilibrium reaction will come to equilibrium, either we start from reactant side or product side. Okay, then these are the two main questions which are asked, like stretching of rubber and boiling of egg. I hope you have gone through this boiling of egg. What is the entropy change? Okay, so whenever we stretch the rubber, that polymer chain is aligned. So whenever there is a stretching of rubber, entropy decreases. Because those coiled chains are straightened up. Okay, so keep in mind, stretching of rubber always decreases the entropy. And boiling of egg, so when we boil an egg, then fibrous protein changes into globular protein. So globules are formed, and that's why entropy increases. So there is an increase in entropy. Do you have some questions related to this topic? Okay, so question is, for the reaction involving ideal gas, A gas plus 2B gas to give 2C gas, 3D gas, which of the following plots is qualitatively correct? Kp and Kc are the equilibrium constant in terms of pressure and concentration. So see, this is question from equilibrium actually. Anyhow, we will have it like, Kp is equal to Kc into RT raised to power delta Ng. So Kp by Kc, that is equal to RT raised to power delta Ng. Now what is delta Ng here? Delta Ng is 2. So Kp by Kc is equal to RT raised to power 2. So Kp by Kc is equal to R square into T square. So that means relation is Kp by Kc and proportional to T square. But we have to plot graph between Kp, Kc versus T. Yes. So when T increases, obviously Kp by Kc increases, yes, but not linearly. If delta Ng comes out to be 1, okay, so see, B and C are straightforward, we can reject, yes, but we left with A and D. So if the relation is Kp by Kc versus T square, then graph will be like this, right? But here in D case, the K, when temperature is even 0, Kp Kc has some finite value. That means D is again rejected. So we left with only one option, A. Because when temperature increases, then Kp by Kc increased, means by power 2, because as temperature increases, then it starts from 0 first and it increases like this. Yes, it should be, see, it is from the origin only. Okay. So I think A option is correct. Is it? Okay. Is it like that? Answer is, oh, yes, it is A, because all the three other options are rejected straight, because first is B option is Kp Kc by T, it is independent of temperature. So that's not true. Then C option is Kp Kc decreased as temperature increases. That's also not true. So D and A options are somewhat correct, because as temperature increases, Kp Kc increases. But in D, that when temperature is 0, Kp Kc has finite value. So you know, when temperature is 0, obviously Kp Kc is also 0. So D is rejected. So we can't think about A, only one option left. So question is, a sample consisting of 2 mole helium is expanded isothermally at 22 degrees Celsius from 22.8 decimeter cube to 31.7 decimeter cube. First, reversibly. Second, against a constant external pressure equal to the final pressure of the gas. And third is freely against 0 external pressure. So for 3 processes, you will calculate Q, W, delta U and delta H. Okay. Now first case is reversible. So you know, in a reversible process, what is work done? Minus 2.303 nRT log V2 by V1, because volumes are given. So it is minus 2.303, N is given to you 2, value of R 8.3 and temperature 22. So it is 295, okay, 295 and multiplied by log of 31.8 divided by 22.8. So in this way you can calculate reversible work done. Next is your calculation. Now what is Q? It is minus W, because it is reversible and isothermal. So delta U is 0, both are 0. So Q, yes, so minus W is minus X, whatever joule, okay, and Q is plus X joule. Okay, so this is first part. Now come to second part. You know, it is against a constant external pressure, and that pressure is equal to final pressure of the gas. So you know, we will apply this formula, PV equal to nRT. It is irreversible expansion, because it is against constant external pressure that I have mentioned, that whenever we have constant external pressure, then it is irreversible work done. Okay, so now what is pressure? nRT upon V. N is 2, R is okay, pressure, so it is should be 0.082 and into temperature 295 and volume, final volume, it is 31.7, right? Because it is written equal to final pressure of the gas. So in this way you will get pressure. Now after getting that pressure, you will apply this formula, minus P external into delta V. So it is minus whatever this value comes out to be, let us say Y atmosphere. So minus Y into 31.7 minus 22.8, but this value comes out to be in liter atmosphere, right? And you know 1 liter atmosphere is equal to how many joules? It is round about 101 joule. But what happened then? You have to take pressure in meter cube, sorry, volume in meter cube. That you can do. See, if you want to use this here 8.314, so you know it is SI unit, so you have to use SI unit of volume, so it should be 31.7 into 10 raised to power minus 3. So that can serve the purpose. So in this way you will get pressure, okay, in Pascal, and this, so the value comes out to be in joule. You can do in both ways. And same, it is again isothermal. So delta U delta H remains same, right? Now come to C part. C part is simply the expansion, free expansion, zero external pressure. That means work done is 0. So Q is 0. Here everything is 0. Yes, P external is 0. External pressure is constant, that is 0. So it is again irreversible, we can say, but it is actually 0. Okay, question is, a piece of zinc of mass 5 gram is dropped into a beaker of dilute hydrochloric acid. Calculate the work done by the system as a result of the reaction. The atmospheric pressure is fixed, that is 1.1 atmosphere, and temperature is 23 degree Celsius. So we have piece of zinc placed in dilute hydrochloric acid, so that will give ZnCl2 and H2 gas. Calculate the work done by the system as a result of the reaction. So when reaction takes place, you know, this H2 gas is formed, delta Ng is 1, and you have, okay, 5 gram, okay, so what amount of gas is formed? Calculate the work done by the system as a result of the reaction. Now external pressure is given to you 1.1 atmosphere, and if 5 gram is dropped, so if it is 1 mole, then hydrogen produced is 1 mole. And what is the atomic mass of zinc? It is 65. 65 gram. So that will give you 1 mole. So if it is 5 gram, then we will get 1 divided by 65 into 5. It is 1 by 30? 1 by 13 mole. So these are the number of moles we will get. So see, in the starting, the volume of the gas is nil. 0. So PV equal to nRT or P delta V, that is delta NGRT. So I think work done can be calculated like this: 1 by 13 into 8.314. Do you have answers? So just calculate it, how much amount you will get. One 89. And what is the answer given? It is negative. Yes, that's true, because it is expansion. Okay, so we write a minus sign here. Okay, because it is work done is minus P delta V, right? So it is minus P delta V minus delta NGRT. So means very close to it. Okay. Okay, next is adiabatic. A vapor at 22 atmosphere at 5 degrees Celsius, it was allowed to expand adiabatically to a final pressure of 1 atmosphere. The temperature fell by 10 Kelvin. Calculate the Joule-Thomson coefficient mu at 5 degrees Celsius, assuming it remains constant over this temperature range. Actually, Joule-Thomson coefficient, Joule-Thomson effect, do you know? Actually, when we have a gas at high pressure and it is allowed to expand adiabatically, then what will happen? You know, temperature will decrease and that gas will liquefy, and that is called Joule-Thomson effect. So Joule-Thomson coefficient is change in temperature by change in pressure. So here, you know, we have 22 atmosphere pressure. Okay. And at 5 degree Celsius, it was allowed to expand adiabatically. That I told you, when a gas is at high pressure and suddenly it is allowed to expand adiabatically, then work is done by the gas, and heat is not supplied, so that will absorb heat from the system itself. Therefore there is a decrease in temperature, and that's why gas can liquefy. So this is Joule-Thomson effect, and Joule-Thomson coefficient is change in temperature divided by change in pressure. So here it is given a vapor at 22 atmosphere at 5 degrees Celsius. It was allowed to expand adiabatically, and final pressure becomes 1 atmosphere. So it is P1 and this one is P2. So delta P equal to final minus initial. So 1 minus 22 means 21 atmosphere, and delta T, temperature fell by 10 Kelvin. Delta T is given 10. So that implies it becomes 10 by 21, because it is we will take magnitude, okay, because it is fall in temperature, so it is minus 10, it means magnitude we will take. So 10 by 21, so what is the answer given?
0.4 Kelvin upon.
Yes, so it is. So see, when okay, so it is Kelvin per atmosphere. So around about 10 by 20 if you take 0.48. Okay, a sample consisting of 2 mole means N is 2, and a diatomic gas. So if it is diatomic, then what is gamma? Yes, 1.4, and at 250 Kelvin is compressed reversibly and adiabatically until its temperature reaches 300 Kelvin. Okay, Cv is given 27.5 joule per Kelvin per mole. So when this is delta U, to calculate delta U, it is N Cv delta T, and Cv is R upon gamma minus 1. Delta U and W are, okay, because adiabatic process is there, so Q is 0, right?
Yes.
Value of Q is given as 0,
Yes, the value is given
and delta U is minus W adiabatic. Sorry, it is delta U equal to simply W adiabatic, means there is no need to apply. That means diatomic perfect gas, if it is given, it has no meaning up to this point. So it is 2.7 kilojoule. Okay, so delta U is same and W is also have same value, and delta H is NCP delta T. 2 into Cp is 35.8 into 50. So what is the value? 3558 kilojoule. Same value is given. Okay, so we get delta U, we get W, Q, delta H, and we left with delta S. So delta S is Q over delta T. So delta S, is it 0? S is also 0 because Q is 0.